Hello folks, this is 2025 May June paper 1-1 and the question number is 14. It is concerned with the chapter of forces, density and pressure, and it is exactly related to the upthrust action. So a uniform cylinder of weight 25.0 Newton is suspended from a Newton meter. So it is simply weight of the stuff. The cylinder is fully submerged in water. Yes, of course. The reading on the Newton meter is 10 newtons. It means that this is the resultant force on the Newton meter, or let us say it is the resultant force on the material of the Newton meter. So it means that the upthrust should be, because here what happens is whenever a body is suspended like this, one of the force it experiences is the force of gravity or weight. The other is upthrust, and that gives the resultant force, and that resultant force is recorded in the Newton meters or balances. So we have got here this resultant force is equal to force of gravity minus force of upthrust. The resultant mean measure is 10 equal to this thing is 25 minus this is upthrust. So therefore the upthrust right now is equal to 25 minus 10, and that's equal to 15 Newton. So here the upthrust force is equal to 15 Newton according to the two data that are given to us. Now the water is replaced by a liquid with a density 10% greater than the density of water. So water being replaced by another stuff whose density is 10% more than the water. So that's why I can say it here as rho nu. Nu is equal to 10% plus density of water. So that means if density of water is considered as a rho, it should be equal to 10% of rho plus rho. So it's equal to, this is 0.1 rho plus rho, that becomes equal to 1.1. Sorry, this becomes equal to 1.1 of this rho. 1.1 of this rho. So rho nu equal to this much. The cylinder remains fully submerged, so it is submerged. What is the new reading on the Newton meter? So we have to find the new reading. So now what happens here is the force of upthrust is equal to weight of water displaced. Weight of water displaced, the initial force of upthrust, that's equal to mass of water displaced into z, and that's equal to rho of water, volume of that solid, into z. So initial upthrust equal to this much, and this is equal to 15 Newton. This is equal to 15. This is the initial upthrust. Now the final upthrust is equal to, so let me use the symbol here. So force of upthrust nu is equal to rho nu, rho of that new liquid, then volume of that thing, it is same, volume of that solid stuff is same, and into z, and that's equal to 1.1 rho vs z, and that's equal to this rho vs z. So rho vs z is equal to 15. So it's equal to 1.1 into 15. 15 is stated here. Rho vs z equal to 15 there. So it's equal to I know it's 16.5 Newton. So new upthrust is equal to 16.5 Newton. Now the new resultant force, F resultant nu, should be equal to this force of gravity minus new upthrust, force upthrust nu, and that's equal to, it is 25 minus 16.5. So this becomes equal to 8.5 Newton. And this is what is recorded by the balance now, by the Newton meter or the balance now. So 8.5, this thing is available in choice number A. So choice number A is the correct answer.